Today's lesson is on organic chemistry, specifically naming of organic compounds. And organic chemistry is the study of carbon-containing compounds. Carbon is very important because carbon compounds make up life as we know it. So you've seen some of these names in the model lab that we've already done, and now we're going to understand where these names come from. So you may have heard of the name ethanol. Ethanol is the type of alcohol that is drinkable, but I know you're not drinking it, so that's a good thing. So where does this name come from? Well, the name has three basic parts. The first part, F, is the prefix that tells me how many carbons there are in the compound, and F stands for 2. The middle, AN, tells us how the carbons are bonded together. AN means there are single bonds between the carbon. And OL tells me something called a functional group, which tells me it's an alcohol, and the functional group is OH. So if I drew this compound, it would have 2 carbons, 2 carbons. There would be a single bond between those carbons, and then on one of the carbons there would be an O attached to an H, an OH group. So let's look at each part of the name. The first part, the prefix, has to do with the number of carbons. And here are the prefixes for the first 10 carbons. So if there is only 1 carbon, then the prefix is meth. 2 is eth, 3 is prop, 4 looks like but it's actually bute, 5 is pent, hex, hept, oct, non, and dec. So some of these you may be familiar with, others you'll have to memorize, but here are the 10 prefixes for carbons 1 through 10. So if you see a name like octane, the prefix oct tells you that there would be 8 carbons in that compound. So now let's take a look at the middle part of the name, which tells us how many, or not how many, but what type of bond exists between the carbons. If there are all single bonds, the ending is ANE. If it is a organic compound with a functional group, then it just occurs in the middle, and then we just use AN. If there's a double bond, it ends with ENE, but if there's a double bond and a functional group, then just EN in the middle of the name of the organic compound. And finally, if there's a triple bond, it would end in YNE, but if there's also a functional group, then YN would appear in the middle of the molecule. So if you saw a name like hexene, you would know from the 2 parts that hex meant 6 and ene meant there was a double bond. So let's look at the third part of the naming system. The third part tells us about the functional group present. And you might have been from the very beginning of this video said, Ms. Backus keeps saying functional group and I have no idea what she's saying. Well, now I'm going to tell you. Functional groups are things that are different than normal. So organic compounds have C's and H's in them. So if we have something else besides a C and H, we call that a functional group. And why functional? Because that's the part of the molecule that often affects its properties and how it reacts or how it functions. So let's look at just 4 functional groups, and these are the only 4 we're going to look at. There's many more than 4, but these are the 4 that you are going to be responsible for. So in our first molecule, we looked at the functional group alcohol. So what makes an alcohol molecule? Well, the functional group is somewhere on the molecule there's an O attached to an H. So if there's an O attached to an H, we call that a hydroxyl group, and a hydroxyl group are present in alcohols. If there's an OH in the group, it has an ending in the name of OL, just like alcohol. And you know alcohols that are common, and one uses that they're good disinfectants. Ketones, what's special about them? Somewhere in the molecule they have a C bonded, double bonded to an oxygen. This is called a carbonyl group, and if you have a carbonyl group in the molecule, It's a ketone as long as the carbonyl is somewhere in the middle of the molecule. And the ending is ONE. And you may know one common ketone, and that's fingernail polish remover is a common ketone. They are good solvents. Aldehydes. What's special about them? They also have a C double bonded to an O, a carbonyl group, but it has to be at the very last carbon or the very first carbon, which is also the last carbon, depending on how you look at the molecule. So if there's a C double bonded to an O at the end of a molecule, unlike a ketone where it has the C double bond in the middle of the molecule, if it's at the end, we call that an aldehyde, and the ending that we give it is Al for aldehyde. And a lot of aldehydes are preservatives. And the last functional group we're going to look at is kind of a combo group. We call that carboxylic acids. And here is what we're looking for to identify it as a carboxylic acid. I have a carbonyl group, a C double bonded to an O, and then I also have an OH group. So it's like a carbonyl and a hydroxyl group put together, and this is at the end of a molecule, and we give this name oic acid, and one common use, well, vinegar is a carboxylic acid. So now let's put all three parts of the name together and figure out what it is. So let's go through this example, hexanoic acid. So if I were to draw hexanoic acid, I would take this word and figure out from the three parts what it meant. I'd start with the hex. Hex means 6, so I know there are 6 carbons in this molecule. AN tells me that there are single bonds between the 6 carbons. So I would put carbons together, 6 of them with single bonds, just like this. The oic acid tells me it's a carboxylic acid. So at the end carbon, I have to have a double bond to an oxygen and an O bonded to an H. And chemists get a little lazy sometimes, and look, there is no bond or stick or line drawn between the O and the H, but it is really there. They just got a little lazy and left it off. So it's really an O line H, but if you want to write it like this, you can. So here is what the molecule looks like. So you might say, Miss Backus, we didn't talk about the H's. Well, the organic chemist assumes you know how many H's to add. Each carbon should have 4 bonds, and you add the H's as needed. So this carbon on the end only had 1 bond to C, so it must have 3 more spaces, and those are with H's. This carbon had 2 bonds already, so it needs 2 hydrogens. Same with this one, same with this one, and same with this one. So the organic chemists assume that you can add the appropriate number of H's to the molecule. Sometimes organic compounds have numbers in them. So why do we have a number with the name? Well, the number tells us the location of something, usually where the functional group is. So let's decipher this name, 2-pentanone. So let's come back to the 2 in the middle and decipher the name. Pent, you probably know without memorizing, is 5. So I have to put 5 carbons. 1, 2, 3, 4, 5 carbons. AN, since they're single bonds, where? Between the carbons. Single bond here, 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 here. All right? ONE tells me that there's a double bond to an oxygen. And it has to be somewhere in the middle because that represents a ketone. It can't be on the end carbon because that would be an aldehyde. So I have 3 choices. I could put the double bond O here, the double bond O here, or the double bond O here. So to know where to put it, chemists will say where the double bond oxygen is. So 2-pentanone means that double bond oxygen is on the 2nd carbon. Now you can count from either end. So you could have put it on this carbon, but that would be the same molecule just flipped over. So here is 2-pentanone. And once again, the organic chemist assumes you know how to add the extra hydrogens so that each carbon counts up to have 4 bonds altogether. Notice this carbon doesn't need any more hydrogens because it already has 4 bonds to it. So let's try one more, but this time let's look at a formula and see if we can name it. So the first thing we're going to do is the prefix, and the prefix tells us how many carbons there are. So we need to count them. 1, 2, 3, 4, 5, 6, 7 carbons. So 7 carbons means the prefix is hept, H-E-P-T. The second thing I need to do is look between the carbons, what kind of bonds they are. It's a little difficult to see, but these are all single bonds here. So that makes it an alkane, and I am going to put an AN in the middle. So now it's heptane so far. And now we have to see if it has any functional groups. Does it have anything besides just carbon and hydrogen and single bonds? Yes, it has this double bond oxygen, and it's on the last carbon. Okay, so that makes it an aldehyde. So an aldehyde has an Al ending. So now we have heptanal. Do we need a number for this? You might think. No, because for an aldehyde there is only one place to put the double bond oxygen, which is on the end carbon. So you could have put it here or you could have put it here, because that's actually the same place, because we could just flip the molecule and see that it's on the same carbon. So there we have it, a little exercise in naming organic compounds. Now I'm going to let you try on your own. Hope you enjoyed listening.